Hello. So this is the third day at DAC 13 in Austin, and I have the pleasure to welcome our next speaker. His name is George Sidiropoulos. You understand immediately where he's coming from. He's the director of a company called Think Silicon. This company is located in Patras. Patras is in Greece, and it's the Silicon Valley of Greece, because there you will find Samsung, Atmel, Intel, and other company. So of course, Think Silicon is still a small company, and maybe people don't know exactly what you do, and what are your projects, and how you target the market. So please tell us a little bit.
Okay. Hello. We're actually designing and developing IP cores in the fields of computer graphics for embedded mobile devices. Our products are complete products. We design the hardware, we're adding the RTL code, but we also provide the drivers for the operating system and a complete API software libraries for industry standards we support, like the Kronos Group OpenVG and DirectFB. Let's say some about our markets.
Yeah, sure.
Okay. We're actually addressing our market is in devices that had some displays and need some graphical user interface. And we're addressing the lower and the mid part of this market. For example, some devices are, let's say, a GPS, which needs a graphical interface, or a voice over IP phone, or other devices with LCD screens. And we are concentrating in designing the products that are low gate count and low power. This is our specialty.
At DAC you have a nice and impressive demo. Maybe you could tell to the audience, the demo is called Think VG. So he will tell you a little bit how this demo looks like and what it's doing.
Okay, you can see here in our booth the Think VG, which is a vector graphics processing unit. And the demo is based on our customer product. Our customer is Dialog Semiconductor, and it's a voice over IP phone. So what about the graphics? Is a vector graphics processing unit based on vShader. vShader is a graphics processor designed by us. It's a floating point SIMD streaming processor, programmable in C and C++, and several hardware blocks in this GPU. And except the hardware, as I told earlier, we also provide the complete software library, and this product is conformant with OpenVG, and actually it's very small. It's the smallest GPU in the market that's conformant with OpenVG 1.1. So there's a lot of work there done from us with our customer in order to make many optimizations in terms to offload the host CPU and the memory bandwidth, which is very critical for this kind of applications. So, except ThinkVG, we have also the LCD controller, ThinkLCD-ML, which is a multi-layer display controller, and also we have a 2D graphics accelerator, which can be used in parallel with a GPU as a composition engine in order to lower more the power consumption.
Okay, so low power is always the right way to go. How do you see your future? Becoming a big company or just next steps?
Okay. We're targeting to launch our new product, which is currently in development, our next generation GPU, which is a scalable solution, which is going to address new market for us, new markets. So we're going to support the Kronos Group OpenGLES standard for graphics, because we are targeting to 3D graphics, but also we have an architecture that can accelerate video decoding and general purpose GPU programming with OpenCL. The architecture is in such a way defined that we can also in the future support acceleration for vision and augmented reality, which are really hot, and it's kind of new applications for GPUs. We are trying to take advantage of the massive parallelism that exists in graphics applications So we have a multi-core system based on NEMA. NEMA is our new processor for graphics, which is multi-threaded. Again, here is our main concern. One of the first things we take care is power consumption. That's why we are part of a project funded by the European Commission, and it's called Low Power Computing GPUs. It's LPGPU. And there we work closely with other companies and universities in the European Union in order to import and to introduce novel techniques for low power. And you can find more information about that in www.lpgpu.org. And so our new design is based on NEMA, which is also powered by a customized ISA and LLVL-based compiler toolchain, completely designed by us.
Okay, so we wish you good luck in the future. So you are supported by European project for some years more?
Yes,
yeah?
Have 2 years more.
3 years more, okay. So at the end, we wish you the big success.
Yes.
Low power in this area.
Yes, what is also important is the customer engagement, and we always try to have an early customer engagement when we design our products. So we are really close to that.
Okay. Thank you.